Today's show is sponsored by StrongDM. Are you managing your remote team as they work from home? Managing a gazillion SSH keys, database passwords, and Kubernetes certs? Meet StrongDM. Manage and audit access to servers, databases, and Kubernetes clusters, no matter where your employees are. With StrongDM, easily extend your identity provider to manage infrastructure access, automate onboarding, offboarding, and moving people within roles. Grant temporary access that automatically expires to on-call teams. Your admins get full auditability into anything anyone does. When they connect, what queries they run, what commands they typed. It's full visibility into everything. For SSH, RDP, and Kubernetes, that means video replays. For databases, it's a single unified query log across all database management systems. StrongDM is used by companies like Hearst, Peloton, Betterment, Greenhouse, and SoFi to manage access. It's more control and less hassle. Start your free 14-day trial today at strongdm.com/cloudcast. That's strongdm.com/cloudcast. StrongDM. Manage and audit remote access to your infrastructure.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. It's good to be back with everybody this week, and kind of a slow week in cloud news of the week. It's kind of hit that peak mid-summer time frame where a lot of people are on vacation. If big things are happening in tech, people aren't necessarily announcing it. Companies aren't necessarily announcing it because they won't know. They know that it necessarily won't grab the news headlines. So instead of giving you a nothing cloud news of the week, I thought we might go back and hit on a couple of stories from a couple of weeks ago when we took that week off for 4th of July or for the holiday. We didn't really do any cloud news of the week because we didn't do a show. So I wanted to hit on a couple of stories I thought were interesting. I know we always like to sort of touch on areas where the technology hits business and it's impacting broader swaths of business. So no real cloud news of the week this week in terms of kind of net new things. Next week's show will hit on the earnings that come out of the big three cloud providers. IBM did announce their earnings this week, announced relatively decent earnings for a COVID quarter, but we'll dive into all the earnings from the cloud providers next week. So I did want to hit on a couple that were out just the first part of July, so a couple of weeks old, not too old. The first was Uber acquired Postmates for $2.65 billion. So obviously Uber Eats is a big player in the space of food delivery. Postmates, another big player. That market is distinctly consolidating. We've seen Grubhub and some others out there as well gaining market share. So we're seeing consolidation around this. Around this space, around the sort of gig economy, around food delivery, obviously with people staying at home with the COVID, we're seeing more and more delivery, especially in cities. But it's interesting to watch some of the consolidation, how this will impact not only prices for delivery, but also a worker's ability to negotiate salaries and benefits and other types of things, and how much this will ultimately impact sort of laws that get decided on a per state basis or on a national or international basis. So some consolidation happening around the food delivery space, and obviously, Uber, a lot of technology behind the scene to make that work. And the second one was Amazon acquired autonomous car driving company Zoox for $1.2 billion. The Uber one was $2.65 billion. So it's interesting, Amazon has been experimenting and investing in a lot of different things, some in trucks, some in other autonomous driving. They'd made investments previously in Aurora and in terms of autonomous driving, self-driving trucks. They had previously invested in a company called Embark. So this isn't a first time for Amazon. Obviously, they are trying to look at what their supply chain looks like in terms of delivery, in terms of potentially, getting into this space from, say, an AWS type of service down the road, right? Some people might say, well, ride sharing doesn't seem like an AWS service, but, also, managed satellite dishes 3 or 4 years ago wouldn't have seemed like an AWS service. So it'll be very interesting to sort of see where Amazon goes with that. If this had been an Amazon service that was named Zoox, obviously Corey Quinn would have probably done a big rant about how they're not very good at naming names and so forth. But they actually just bought the company called Zoox, so we'll see if that name continues. So kind of interesting to see where that's going, especially the price tag of the autonomous vehicles being $1.2 billion seems sort of low for something that can be so incredibly impactful in terms of society, in terms of impacting the automotive industry, the transportation industry, ride sharing, all sorts of things. So interesting price point. Sort of feels like sort of a low price point to be getting into something that has such a huge impact, especially when we look at the price point of some of the tech acquisitions that happen over the years, on the IT side, where the numbers are often much, much larger. So with that, we're going to wrap it up for Cloud News of the Week, or sort of a lack of Cloud News of the Week. We will be coming back again, like we said, next week with all the earnings numbers from the cloud providers. Interesting conversation we're having this week, because we're going to jump into the interview in just a second. We're going to look at a new topic, kind of a new concept called data mesh that we'd never really heard of before, but we had a chance to really dive into it, had some fun with that, and I think you're going to enjoy that right after the break. Today's Cloudcast is brought to you by Datadog, a scalable monitoring and analytics platform. In their latest report on container trends, Datadog analyzed 1.5 billion containers and found that in 97% of Kubernetes environments, container lifespan was under 30 days. To help you visualize and manage this dynamic infrastructure, Datadog seamlessly integrates with over 350 technologies, such as Kubernetes, Docker, Amazon ECS, and much more. Plus, with Datadog are container-specific features like the live container view and the container map. So try Datadog today for yourself with a free 14-day trial, and you'll receive a complimentary t-shirt. Just go to datadog.com/cloudcast. That's datadog.com/cloudcast. And we're back. And folks, we always love to obviously dive deep into a lot of different topics. There's lots of things that people are always really excited about. And then there's some unique times when we get a chance to really talk about a topic that, at least to us, and the point of the show is always to try and educate ourselves and educate you. We get a chance sometimes to really talk about something that pops up on our radar as being kind of new and unique. And we're always excited to have a chance to really dig into that. So excited today to have a chance to have Zhamak Dehghani, who is Portfolio Tech Director at ThoughtWorks. Zhamak, welcome to the show. Glad to have you on the show.
Hi, Brian. Thank you for having me.
Yeah. So we're going to dive into this topic of data mesh, and we kind of got introduced to it through the O'Reilly series of shows before the COVID sort of took the shows away from us. But we got introduced to it, and we were looking through the catalog of topics, and we were like, I've never heard of that. It looks incredibly interesting. And so we're excited to talk to you. Before we dive into that, give us a little bit about your background. You've done a lot of interesting things at ThoughtWorks. You've been around software development and building unique systems, but give us a little bit of your background for the listeners.
Sure. Thank you. I've been around in the industry for 25 years. I can't imagine even saying that. That sounds like a very long time. Make me feel old. And from within that 25 years, I've done a lot of different things. But if I look for one thread that has been common across everything I've done, is really focus, love, and passion for distributed architecture, decentralization of systems. So I've done work in distributed system architecture at the networking level, and building applications that by nature requires protocol design. I've done a little bit of hardware. I've got a bunch of patents around that. And at ThoughtWorks, at least for the last 12 years, my focus has been around distributed architecture at the enterprise level. So that would cover things like microservices, and then all of the tech stack that requires to run it and monitor it and support it, from cluster management, service mesh, and so on. And for the last 2.5 years, my focus shifted to kind of big data and analytical data. And I thought, well, there is one place that we haven't really blown it up into small pieces and make it decentralized, whether that's a good idea or not. But that's kind of the mission I'm on. So my focus has been on kind of bringing the experience that we've had with scaling operational systems to big data and big data analytics, and really introducing system architecture that hasn't really existed before to that space, because we're going to a world that data is ubiquitous, and the patterns and paradigms that have worked in the past really don't scale to this new world.
Yeah, and obviously ThoughtWorks has been, not only kind of at the forefront of helping to define a lot of these distributed paradigms, but doing a ton of actual hands-on work with companies to go implement it, to go find ways to do it well. Probably learning a lot of lessons about sometimes how to not do it well and so forth. So the opportunity to speak with you, having the background that you have, the experience you have, is very exciting. About a year ago, you introduced this new concept called data mesh, And before we get into data mesh, it kind of builds off of, to a certain extent, the learnings of things like data warehouses and data lakes, which obviously got a lot of buzz, a number of years ago. Talk to us a little bit about what you saw as problems with like big, kind of data lakes, the concept, and what became the origin of data mesh.
Sure. So, when we talk about data means it has different meanings and has a different usage in different contexts. But maybe perhaps just before getting into what's data lake and data warehouse or data mesh and what that, journey looks like, the journey of evolution looks like. For a moment, if we think about kind of different categories of data that we usually deal with, on one hand, we have our operational data, right? The data that lives in the databases of applications that runs the business, the e-commerce application or order management system or claim processing. Mm-hmm. And those operational data for a long time, we've been, working with various type of databases. We know how to hide that data or how to model that data, how to build like services and APIs on top of it to abstract capabilities that would use that data and change it. So in the operational world, I think, there are lots of patterns and paradigms how to manage, NoSQL data, document-based data, and so on. But essentially, the data is on the inside and hidden behind capabilities of that's actually, applications that run the business. But on the other side, we've also had this concept of analytical data or big data, which is around, data sets that are almost always representative of the historical information that has happened running the business. And that historical information in large volume can give us insights into what is happening into the business. And then go beyond that, with machine learning and AI, how can we use this now historical view of large amounts of interconnected data sets to actually create, automated decisions that now we can make, right? And in that category of the system architecture around managing that analytical kind of big data sets for whether it's for, analytics and business intelligence and reporting or, training machine learning, that system architecture has been quite kind of separate, right, from the system architecture that we've applied with our operational databases and operational data, and it's been cornered often to a different part of the organization managed by a different team, BI team or data analytics team, and so on. And as the businesses kind of evolve, the digital native and, native data-driven organizations like the Uber and Lyft and, Airbnb, that actual business of, actual capabilities running the business need the data, right? You need that historical data, analytical data to actually tell me when my, ride will arrive. Apart from those companies, often the technology for managing that big data is very, very independent. I mean, with Uber and those companies, those technologies intersect quite a bit. So then, going back to your question of where does this data mesh fits in that evolution of managing kind of analytical data? I think, historically from decades, we had the idea of data warehouse. And the main paradigm or main, I guess, assumptions and characteristics behind that were that, these operational data sets and databases and systems are somewhere running in the universe of our organization. And what we're going to do, we're going to run a bunch of scripts that will go into those databases, pull the data out, and model them into this beautifully bottled data, which is essentially, a lot of tables that are interconnected so that we can run a bunch of SQL queries at scale over them, and then so that we can, generate a bunch of reports that will tell you what are the trends of our business, like what's the sales trends, what's the market capture, whatever business intelligence we get out of it. So that was kind of the model of data warehouse. The purpose of it mainly was used by people, not machines, sitting in front of the reports and analyze them. And the idea was that was a very, very separate technology, from the operational systems or operational domains that are running the business. and there would be a centralized team to take care of it. And often the technology landscape for the data warehousing involved a lot of full stack proprietary kind of technology, like the likes of Teradata. There is no, sorry, so just disclaimer, there's no embracing or criticizing any of these technologies, just examples to mention. And then in more modern kind of world, you have the BigQuery in GCP, or you have Power BI in Azure, and so on, which are really full stack technologies to put data in some sort of a SQL queryable format. And then the world evolved as we introduced more data science at scale and machine learning at scale. This cumbersome and time-consuming process of extracting data from databases that are continuously evolving and breaking these extraction scripts and assuming this centralized, beautifully modeled data will answer our questions. That process became questionable and not really relevant to a world where you actually want the data in its raw format. You want to be able to explore all of the noise as well as the signal to figure out what's going on. And that's kind of the job of the data scientist and machine learning engineer. So there was an evolution around 2010, this idea that, well, instead of extracting the data and bottle them nicely and put them in one place, why don't we just get the data in its native format, get the data from those operational databases, still in that, extract kind of load transform, extract them, put them in one place, put them in raw format. So, object store, file store kind of format. And then, unleash the data scientists to go and figure out what it is that they need. And once we figured out what it is that we need, we get out of the data, then we build some purpose design kind of databases, APIs to get access to a bunch of modeled data, later modeled data. And that was the idea of data lake, introduced by James Dixon. And that worked well for a small size. But the challenge and the challenge with that was that there is still an assumption that it's a separate group of people dealing with this big data tooling, getting data from these domains that, again, are very volatile, continuously changing, going into their databases, getting the data out and put it in one place. And the assumption is that people will come here and magically make sense of it and find this data useful. And then we see this, set of technologies around that, various blob storage and, various technologies like Hadoop clusters and distributed file system and distributed query languages and Presto engines and Dremio and a bunch of other technologies to kind of manage that distributed file system, but yet a centrally managed, essentially, data lake. Data mesh challenges all of that. So it's a bit of a left field paradigm shift coming from thinking about how we can decentralize ownership of this analytical data. The same, evolution that we went through from kind of monolithic applications where you have monolithic teams and monolithic architectures and monolithic infrastructure to run business to breaking that apart into self-serve, easy to consume, pieces of the data as a product. Similarly to microservices, similar to that transition. So data mesh is challenging those paradigms and trying to bring a bunch of principles like decentralization, like product thinking and platform thinking into the world of big data.
Yeah, no, I think it's, and for anybody sort of listening to this going, wow, that's a lot of new stuff. And I'm trying to wrap my brain around it. There is a outstanding paper that you wrote, outstanding article that you wrote that really kind of goes into this with a bunch of very good diagrams and visuals. So if you're listening to the show and you're going, okay, how am I going to remember all these things? Don't worry. We're gonna kind of walk through the basics of it, but there is a tremendous article that'll be in the show notes that you can dive deep into it. So let's kind of walk through data mesh, and obviously you talked about it being different than data lake. Data lake was the concept of like, well, hey, if data is in all these different places, how are we ever going to kind of connect the dots or, create correlations between things? So then we brought it all together in one place, and that turned out to be kind of difficult to deal with at scale. Where does data mesh begin to start to say, okay, let's go find ways to use the data because we have it, it's there, but let's start to use it in interesting ways. So what are some of the core concepts, that it begins to introduce to make it, like you said, begin to look like what we do with applications and domains of applications and those types of things?
Sure. Okay, so this is going to be a long part of this discussion. So please interrupt me anywhere that you feel like I need to explain a little bit more. Yeah. Okay. So I guess one of the foundational concepts that we is part of the principles, but also we try to kind of materialize into a component of the architecture. This idea of a data product or a data node. On a mesh, right? So the idea is that if I have an analytical data set, so I have, time series or snapshots of events or snapshots of changes that happen to a particular data set, like the data set could be the claims. Let's say these are like the insurance claims or pharmacy claims that members of a health organization are making. And we want to provide that view, that kind of immutable analytical view of all of these claims that have happened. We say, okay, there is a claims domain in this organization, and the job of this claims domain is to process these claims and, serve the customers. But also, now in this data-driven world, this team has another responsibility. And the responsibility of this team is provide analytical claims data products to the rest of the organization. So what are these data products? So data product essentially is the quantum of architecture in a data mesh, is a node that encapsulates both code and data. And its job is to process and store and serve this infinite, essentially, log or files of that particular data, and serve that data to the rest of the organization through well-defined schemas and APIs that provide access in a multimodal fashion. So in this particular example, a claims data product would be a combination of code and a combination of storage and a combination of a bunch of access points or endpoints or APIs that allow the claims data sets, claims analytical data sets, to be discovered. That would allow the users to say, oh, where there is a claim database or data sets or data product, I want to know more about it. So they can go to that data product and get more information about its schema, download a sample file to say, oh, I can see that there is, claims events that have high resolution, probably, low quality because there isn't a lag in the processing. So the events probably have maybe some missing information in them. But there's also an aggregate version of these claims that I see them as, JSON files, snapshotted daily. And there are different ways that I can get to it. So there's an API that I can get to that claims data that ultimately takes me maybe to a big data kind of big table, or however we implement it, or a BigQuery, or a lake storage, or an event topic, essentially, for that data product. And if you just expand that idea to say it's not just the claims domain that will provide a claims, data product. There is the labs domain that provide all of your lab results that you've done. There is a prescriptions domain that will provide all of your prescriptions that you've received, and so on. You end up with this mesh of data products or data nodes that providing this historical view of the data for their domains. And then there are kind of some platform capabilities put into place to kind of bring these nodes onto the mesh so that they can join and they can kind of correlate with each other. So I pause here to say that data node, or data product we call it, is one of the foundational concepts of your data plane, in a way, the mesh that all of these data sets can exist and can link to each other.
Yeah. So, okay. So the first thing I'm kind of hearing, at least conceptually, is instead of thinking about it being this necessarily just a place where all this data is, you're now introducing the concept of, you call it a product. It could be, a business problem. It could be, kind of a domain thing. So you talked about claims, and it's kind of connecting that business problem, that business domain, probably a certain amount of code that exposes how you're going to look at all those different claims, and then obviously that chunk of a data set or a blob of a data set, and that whole thing then becomes something that the company can either go use or reuse in new ways, but it's kind of beginning to build up out of what was that data lake into something that becomes more of a business domain problem that hopefully becomes a reusable type of thing. Is that A good start.
Absolutely.
Okay, great.
Absolutely. I think pushing the responsibilities to the actual business domains, or even maybe their technical counterparts that are taking care of that domain, is the first thing. Like right now, it's a lot of organization. It's a very well understood paradigm where a particular group in tech or tech plus business are responsible for a particular capability of that business, right? They provide APIs or they provide a bunch of applications that the end user can use or the business user can use. But the lack of responsibility to own and serve the analytical data from that domain doesn't reside there. It resides with somebody else that is far, far from them in one centralized group. And that also leads to a very centralized way of architecting your kind of the big data platform. And there is a while we're saying and we can talk about that in a little bit, but why there is a logical distribution and decomposition of this architecture around the domains. There may be that underneath all of this, the physical layer may not be that fragmented, right? So it might be that the physical layer where all the data resides might be a single lake storage or a single locality where all the data can be in one place. However, how we provision and configure each of these data products should provide that logical decomposition. So each of these data products, the data node, can be deployed and provisioned very independently of the other ones.
Gotcha. Okay. The next thing is I was digging into this and kind of trying to learn about it myself, is this concept of pipelines, kind of pipelines through the data mesh, and the idea of like creators and consumers. Can you talk about what the pipelines do? I mean, they're not sort of CI/CD pipelines in the sense that we think about automating code, but like, what is this concept of pipelines, and what are they trying to convey through the mesh?
Sure. So usually data pipelines, and we can talk about both pipelines, CI/CD pipelines and data pipelines, and where do they fit within this concept of architectural quantum of data product or data node on the mesh. So data pipelines usually are, responsible for moving data through a set of transformations or through a set of functions, reading data from one place, doing some transformation over it, writing it into some other place, and then, another task will pick it up and do some other transformation and write it some other place. And usually these pipelines in a traditional kind of warehouse or lake are constituting the processing that happens on the data to cleanse the data or aggregate it with other sources, or storage it in certain, model the data and model it and store it in a certain format. So that's generally the job of data pipelines: move data from one place to another place, usually from this operational system to your lake storage. Along the way, do a whole lot of processing to make it ready to be consumed. And often in a data lake or data warehouse, data pipelines are your first class architectural concerns. And that what that means is that, when you look at, if you go far, far, far and squint your eyes and you look at your architecture, what you see is a labyrinth of data pipelines that are just like, stitched together, very fragile from the system architecture point of view, because change in one of those steps on your pipeline, whether in the source, a developer changed whatever they were instrumenting to produce the source data, or the raw data changed, has a cascading effect to break a whole lot of other things. In the data mesh world, we kind of take some of those, good architectural patterns like abstraction of interfaces and hiding complexity and decoupling it through contracts. And we say data pipeline are a second-class concern when it comes to the architectural decomposition. If you actually do the same exercise, go far back and squint your eyes and look at the architecture of a data mesh, what you should see is actually a mesh of interconnected nodes, that each of these nodes are connected with each other through a very clear contract and interface. So if I have, for an example, a claims domain that is providing the members' claims, processing and request, and then I have another domain that shows the members' profile, and I could have a third, data product that is, recommendation to members to change their behavior, like intervention of members' experience, intervention to give members some tips to change their behavior because, they need to do something to improve their health. They
Right.
go do their monthly check or annual check. So these three data products, if you squint your eyes back, you will see that they have ports that they connect with each other, the input and output ports. So the output port or output interface of claims and members can go into an input ports or input interfaces of this members intervention data product. And that's the story, is that you can kind of, through these contracts and interfaces and APIs, link these data products to create new composite kind of data products. However, the concept of the pipeline as get the data from one place and then process it and send it to another place without these clear interfaces, without clear, I'll call them output input ports on a data product, interfaces that still exist within the implementation of a data product. So if you actually now zoom into one of those nodes, you probably see a bunch of pipelines that don't have, abstraction around their interfaces. They're just, a bunch of code that would move data from one place to another, and they do transformation. So in this example, if you zoom into that members intervention data products, you will see claims data coming in, getting copied somewhere temporarily, members data coming in, gets copied, and then goes through, data processing, whether you're using, Dataproc, Beam, Spark, whatever the tool of choice, and you're reading these data frames and you're, joining them together and, removing some noise and adding maybe some attributes to it and running some machine learning on top of it to say, okay, which members actually finds into the, fall into the cohort of people that we need to pick up the phone and give them a call. And then that pipeline itself, which is a very common construct in the data engineering world, that would be a second-class concern. It would be an architectural component inside that node that you won't see it when you squint your eyes and look back. You will see it when you zoom in.
Okay. Yeah, no, that starts to make sense. And again, I think as you talk about sort of the modularity, known endpoints of these different kind of data products, it starts to make sense if you think about it, the same way we do with microservices or any other distributed thing. You want to make them, kind of independent in their own domain. You want to make them addressable so that you can reach them. You want to be able to put security constructs around it and so forth. Very cool.
Yeah. I often actually, I should probably mention this. I often get this comment or question that, well, these are all data services. Why don't you call them data services? And, naming things is a really, really hard thing to do.
Yeah.
So the reason I didn't call them data services, because service has this connotation, that the name service has this connotation that it provides a capability. And you ask a question from a service, it will run some logic, it will probably update some state as a result of the request that you sent, and it will send you a response, right? So sometimes we associate services with capabilities that have side effects. They change state, such as, put my order through or put my claims through. So claim service, it gets a request, it changed state, it run some logic and send you a response. Data products or data nodes are very different, in that they are only read-only. They never actually change the state. They only append the state, because we're talking about analytical data. And we're talking about a world that the change need to cascade gracefully, and don't worry about this kind of transactional guarantees that we need to have. So data products, even though they have probably an interface similar to other services, they will have an API to say, give me the address for the bucket where the daily snapshots are, and then you will get an address to an underlying technology like, object store or, big data storage or whatever that technology is. And from there, you use the APIs of that technology to get to the data. But it's always in a read-only mode or an append-only mode when the data comes in. So that's why I wanted to refrain and not use the word service. But you could absolutely think about them the same way we think about microservices in the operational world.
Gotcha. Makes sense. And yeah, like you said, naming is hard. naming is always hard. There was an interesting concept I saw in there that you talk about, kind of the truthfulness of data, and then you kind of align it to a concept, and I'm wondering if it's meant to be the same thing, like an SLO concept, which I know we talk about like in the SRE world, service level objective. How do you talk to me about this idea of the truthfulness of data, or how much you can trust data?
Yeah, and I think it is a really integral part of this because the reason I called this thing data product, not a data service, was the emphasis on the quality of the data. So it's consumable as a product, and it can really delight the experience of the user of that product, which in this case are often data analysts and data developers and data scientists. But how can we guarantee that? Delight of experience? How can we quantify the quality of the data? So and it's very similar to the SLOs that you have a set of metrics or objectives that you can measure and can quantify, and then you can guarantee, right? You can broadcast and then guarantee your uptime, your response time, things that make sense to the services. I think data products at some level, they have to support those typical SLOs that you have for services like uptime and so on, because these are also have some underlying service implementation.
Sure.
But also on top of it, they have to support what constitutes the quality, the metrics that constitute the quality of the data. So some of these metrics might be, the liveliness, how often this data gets refreshed, right? And you have various rates and various guarantees for those. It could be maybe the level of error in terms of like missing fields or missing information. So the more, I guess, real time or near real time there is less opportunity to look at a wider window of data and be able to kind of fill in gaps or distinguish anomalies and we can fix, right? Sometimes there's missing information that if you buffer the data for a longer period of time, you can kind of guess and have a best guess estimate of what could the missing data be there and added to the data, but that reduces the delay, right? Increases the delay by which the data is available. So the other one could be accuracy or the missing information that you might have or the noise that you might have in the data. So these are some of the parameters that we can define as the guarantees and SLOs essentially for these data nodes and data products.
Gotcha. Makes sense. Let me ask you one last question. I want to be conscious of time, but also anytime we introduce kind of a new concept, data mesh being at least fairly new to this podcast, people will kind of internalize it. They'll start to think about it. And then, people are involved and they start to say, okay, well, how would this affect me? Like if this was in my space, what role do I have? What roles expand? What roles change? Have you gotten a sense yet as this is being implemented by actual companies? Like, what are some of the key roles that come out of this, or what are some of the areas that change? At least sort of noticeably change.
Really good question. Absolutely, there are changes, and I can put those changes maybe in the context of some of the big components of this. So right now we have a lot of, let's say, infrastructure engineers, right? That they provision and they write their Terraforms and have their build pipelines and they provision various parts of infrastructure that runs applications. You have infrastructure engineers that are, configuring Kubernetes clusters, or you have infrastructure engineers that are owning and running Databricks clusters or Cassandra clusters and all of that. So that the role of infrastructure engineer extending to a data infrastructure engineer, which I think has happened regardless. It's not new because of data mesh, but data mesh emphasizes and extends that role to a data platform engineer. And that role, basically, the responsibility of that role is provisioning and creation of all of the technical assets and, the really technical, complex assets that require to be provisioned so that these autonomous teams can, on the top of this platform, be able to run their data products, be able to process data at scale and serve data at scale without really worrying now about, my Databricks cluster or my Spark cluster or whatever else they need to set up. So I think the typical infrastructure engineer role would extend to data infrastructure as well as the data platform, which provides that self-serve interface for the data developers that really don't want to deal with the complexity of setting all of the data infrastructure, and provide a platform and interface to them. So it's not purely writing a bunch of Terraform scripts and run them and then monitoring, the stuff that are running in production, but also on top of it is actually defining interfaces and code that allows in kind of declarative way and easy way, a data product developer be able to get all of the infrastructure that need. So often these data products are quite complex. Right now, if you look at microservices world, you write a few lines of Golang and then, build your Docker and put it on Docker Hub and then, download it and push it and run it on your Kubernetes cluster. And it's fairly, it's not easy, but it's fairly well understood, right? The technology landscape exists. If you want to do a similar thing just for a data product that provides like two types of access, let's say it provides both a file-based access and SQL-based access, you would need, and because we're talking about big data, you would need a bunch of services as sidecars, like running on some sort of a cluster. You need, Dataproc or some sort of a Spark cluster to run your data processing job. You need big data storage. And the storage accounts around it. You need some tenancy on some sort of a big data SQL database like BigQuery. You need some sort of a topic or tenancy on an event log or an event streaming system. So you've got to like abstract all of these pieces together and then say, I'm going to give you a data CI/CD pipeline that will provision all of these pieces that you need so that you can easily now write a bunch of code that, actually deals with the data processing itself. So that's the role of data platform engineer. And because we treat that layer as a product, there is actually a product, very strong product ownership responsibility there. So we have roles such as data platform or data infra product owner, a technical product owner who is himself or herself is an advanced user of those data infrastructure, so he can or she can have empathy with the users of that infrastructure and then can define those, the layer of the platform really as a product to the rest of the organization. So data platform engineer, data infra engineer, and data platform product owner. And then on the node side, the actual, data that sits on top of that platform and those nodes on the mesh, which are very domain oriented, and you really need to have the knowledge of the domain. We introduced this role of data product owner, so domain product owner, people who intimately know the data, understand the data for that domain, and become the custodians of the data. And their responsibility is growth of the users and delight of the users of that data. So if you talk to data scientists in an organization, they're always hungry for data. They're always hungry to use for data. So that if you, as a data product owner, you want to make them really happy and make their job really, really easy. And data engineers, to be honest, in a lot of our projects, we don't have a lot of like specialized kind of data engineers. We might have token data engineers here and there embedded into the teams, but we're really trying to stretch the generalist software engineer to just learn a few tools here and there around data engineering, and through the abstraction of complexity through that data platform, hopefully that ramping is fairly rapid, and then they can just act as data product developers, right? And
Gotcha.
that we can close that gap between the data engineer and software engineer.
Yeah, no, and that last piece is really important. If the lift to get to that new capability is really, really difficult and hard, it's also very easy for people to kind of give up on it. So Zhamak, thank you so much for kind of introducing us to this concept and diving into it with us. Folks, as we mentioned, there are a lot of really good resources that we have in the show notes that she had written with herself, as well as some of her coworkers, folks like Sam Newman and others. This has been fun. Thank you for taking the time to educate us, to kind of fill us in on these things. If folks want to, maybe pick your brain a little bit or learn a little more about this space, what's maybe a good way for them to learn more or reach out to you?
Sure. They can reach out to me on Twitter or LinkedIn. My Twitter handle is Zhamak D, Zhamakd. And folks can find me on LinkedIn as well. And happy to respond to any questions. Thank you so much for having me, Brian.
Yeah, it's been great. And we'll have those in the show notes as well. So folks, as always, thank you so much for listening. We appreciate you taking the time to listen to the show. We also appreciate you giving us some feedback, reviewing the show on iTunes and other places where you get the podcast. So with that, for myself, for Aaron, and for Zhamak, thank you so much for listening, and we will talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.